first lightning talk, which will be from Charlie Drage. So Charlie, I think floor is yours now.
All right, perfect. Thank you. I just want to say thank you to Lenka as well for organizing all these talks and everything. It's day 2, so and I'm sure that there's a lot going on today and yesterday. All right, so I'll start with my presentation. I thought it would be nice to propose this to container plumbing because honestly, I don't see many presentations nowadays with Compose to Kubernetes. There used to be a lot of Compose presentations when it first came out and a lot of activity. And yeah, like a lot of developers have moved on to Kubernetes and trying out deployment to that. And yeah, it'll be nice to show how we go from Compose to Kubernetes, the caveats, interoperability, and transformations. So I work at Red Hat. I work on Podman Desktop. Think of it as Docker Desktop, but the cooler version. No bias at all. But I am a core maintainer and contributor to Kcompose, which is a tool to go from Compose spec files to Kubernetes. So I got a lot of experience with dealing with the caveats and problems that we had going from the Compose spec to the complex Kubernetes YAML. So I'll quickly go over this talk and just describe all the bad parts and the good parts and the future parts. If nobody knows what the Compose spec is, I won't have time to explain that, but I'm sure everybody knows what Kubernetes is as well. So we'll go to the caveats first. The first one is there is a lot of transformation happening. The Compose spec is very simple. This is a very simple application of Redis master, Redis slave, and a front end. And converting that to Kubernetes, there's so much. I had to put it in like type 4 font. Ridiculous. There is a lot of conversion happening just to get the same application on Kubernetes. And that's why Kubernetes is complex. There's a lot of stuff happening and a lot of small configuration changes they have to do. The second one is there's no 100% conversion. We could get like 99% of the way there, but there's never 100% conversion from the Compose spec file to Kubernetes. Kubernetes is super complex and cluster-based. Compose is meant to be single host. This is a very small example where we kind of tried to bridge the gap by doing labels. So we did a label of Compose service type node port that will convert it to node port in Kubernetes. So essentially, there's no 100% conversion. How we did that is transformations. We did labels. We improved the Compose spec. So we contributed upstream, had suggestions to it. There is, there's continued contributions to Compose. There's also a new deploy section of the Compose spec. It's meant for cloud providers, not necessarily Kubernetes, but that simplifies things such as creating ingress, domains. There are basically halfway solutions. So interoperability there is now a spawn of different CLI tools. So if you browse Hacker News or Google around, you'll see that there's different CLI tools to try and simplify what Compose is to Kubernetes. So there's different solutions out there. There's Tilt, which was bought by Docker. They have their own format. There's Scaffold. Development has kind of slowed down on there, but it's a Kubernetes-like YAML for your application. There's also Oto that we have within Red Hat that uses the CNCF dev file. There's basically new standards coming up to try and bridge that gap between Compose and Kubernetes. People realize Compose is nice and simple, so they try and make that for Kubernetes too. There's also graphical interfaces being made. There's, of course, Podman Desktop, what I'm working on. that has compose support and conversion to Kubernetes utilizing Podman underneath. There's also Docker Desktop with just straight up compose support, and then you can bring up your own Kubernetes environment, which all three of them can do too. Podman Desktop, Docker, and Rancher all bring up Kubernetes environments. Rancher Desktop, there's very limited support for compose. So what's next? Could be more graphical interfaces. There's some tools out there which are starting to use interactive CLIs, and possibly another spec. Who knows? They're contributing to the compose spec with deploy, but who knows where we could go from here. People are coming up with different solutions to try and reach Kubernetes-like level with the compose spec. All right, I'm 20 seconds over. That's my talk. Well, welcome to my TED Talk.
Thank you so much, Charlie. So now I will encourage everybody to write the questions in the chat, and I will give a talk to the Holger and Kevin, who will talk about hash-based detection of confidential files in container images. So Holger, Kevin, floor is yours.
Yeah, thanks, Lenka, and also for the quick introduction, Holger. And I'm glad to see so many container folks around. And both me and Kevin work for the part of Atos in Germany that's called Science and Computing, and closely work with a lot of engineering teams of automotive customers. And yeah, luckily in the recent years, we managed to get them interested in containers for the engineering and HPC workloads. And so we decided today to share a bit of what we're working on internal projects. So with me today are two of my new colleagues that recently joined us, both Kevin and Cedric. They both did their bachelor's thesis with us, both with a project focused on containers. And yeah, the idea was just to share a bit of the outcome and maybe give you some inspiration. It's not necessarily production-ready code, but you can find some snippets of the projects on GitHub. And if you should have any questions, feel free to reach out to us. So the first talk we're going to give today is a spin-off of Kevin's thesis topic that was dealing with vulnerabilities and confidential data in container images. And he worked on an analysis stage that we see as a part of a multi-stage image analysis process before releasing images to the wild. And Cedric's thesis was concerned with making use of additional security boundaries for a containerized workload. And yeah, he's going to share his rage against the machine if a containerized process goes rogue, and yeah, how to take care of it with eBPF. But let's start with Kevin.
Yeah, thank you, Holger. I welcome you to my lightning talk about hash-based detection of confidential files in container images. The motivation behind and the reason why is there are some best practices how to build container images, but sometimes users still ignore these, and also sometimes sensitive data files are put in container images, and this results, for example, that these images shouldn't be pushed into public registries. And the main goal, therefore, is to tag confidential files in container images. This is based on the hash values of the specific files, and it requires to maintain a database where the hash values of these files are stored in. But I will come to this on the next slides. And also, as Holger said, if you're interested, this code is available on GitHub. To achieve this goal, I used the Review Image Scanner. It allows you to bring your own plugin, and I called my own plugin the hash checker. And the idea behind this is quite simple. First of all, the image is mounted on the host, and the hash value of the image content is calculated. And after the comparison of the calculated hash values with the database takes place, and if there's a match identified, then we'll know that confidential files are included in the image. And on the other side, if there's no match, then there is obviously no files included. And as I said earlier, there are some requirements needed, and one of them is the database. for which I used a simple SQLite database. And in a snippet, you can see what it might look like. Here we have assigned an ID with the hash values and the names of the files. And in addition, we added an extra row called the classification, and it is given in which the confidential of the file can be specified so that I can decide myself how to handle with this image. And the second thing that is needed is, obviously an own image with some files we want to detect. And finally, the trivia checker, which is needed, for which I have explained earlier the concept of. So the execution also looks very simple. First, the trivia is called with the hash checker plugin, and then the image and the database to be compared are followed. And in this picture, both are executed the trivia on my own image, the var1 image. And as you can see, we have found some matches there. And you can also see the hash values at the path in the container, or where you can find them in the container, so that you maybe can revise the container. And yes, and in the picture below, I used the same for an official Ubuntu 2004 image from Docker Hub, and with no surprise, there aren't any secrets found. And yes, that was basically my lightning talk. If you have any questions, feel free to contact Holger or me.
Yeah, just a quick remark from my side. The idea is not necessarily that it's considering files that do have a certain file classification, as we see sometimes with our customers, but also to have a meaning place for software that we want to be able to flag inside an image that is not detected by any of the traditional image scanners. Because in our field, we often see applications that you have to broaden to the image on a custom base because it's CE software and you have to add this. And we want to have a tool to be able to say, okay, we found something bad in this image, and now we want to be able to scan all of these, and then we can just add the hash for this bad piece of software to this database. Yeah. So Lenka, we would straight move over to Cedric's talk.
Yes, feel free to do that. Thank you. It's very easy for me now. Thank you. So go ahead.
All right. So thank you, Holger, for your nice introduction. And I welcome you all to my lightning talk with the title Terminating in the Name of eBPF. As Holger already mentioned, I'm Cedric, and I'm with Atos Science and Computing. And I finished writing my bachelor thesis like a month ago. And during that time, I also looked into seccomp and podman containers, from which a tool evolved that I will explain to you now quickly. So what is the goal of that tool? Seccomp is a nice and straightforward way to increase security of containers because it allows you to block system calls that are not necessary for the operation of the container and could be used for attacks. This blocking is done by applying a seccomp profile at the container start, which is also possible to use with podman. When a process inside a container offends against seccomp, depending on a seccomp profile, the process is, for example, blocked or killed. But what we wanted is not to only have the process killed, but also the whole container to be shut down. Why did we want to do that? Usually when a process is blocked or killed by seccomp, the parent process is still running, and so also our containers are still running. Now imagine having an attacker or some malware inside the container. Their individual actions might be blocked because of the seccomp profile, but the container is still running, and they could try out other stuff or maybe use overseen system calls that are not blocked by the seccomp profile. That's why we want the container and potential threats to be shut down for good after a seccomp offense happens. So one way of achieving that is using eBPF. eBPF is often used for tracing and debugging processes and events on a system, and so does the tool that I've written. There are two components in this tool. One component is using eBPF, running in kernel space, detecting exited processes, and determining if they were killed because of a seccomp offense or not. And the other component is running in user space, identifying and shutting down the according podman container. So currently, seccomp offenses are spotted by the tool by checking if a process exited with signal 31, if it exited abnormally, and if its seccomp mode was set to 2 or 3. Seccomp mode 2 means that the process had a seccomp profile applied to it, and mode 3 is not so well known, and additionally means that the process even was killed by seccomp because it violated the seccomp profile. When such a process is spotted, the owner of the according process and container needs to be found out. If you determine the owner of the process itself, you get the user from inside the container, but not necessarily the actual owner of the container on the system, because the UIDs inside, in our case, podman containers, are mapped to different values on the actual system. This is why the tool determines not the owner of the process itself, but the owner's UID of the process's PID namespace, which usually is also the PID namespace of the container itself, and therefore like the real owner of the container. Because there also doesn't seem to be an identifier for containers in kernel space, the ID of that PID namespace is then determined to later identify the container that needs to be shut down. The shutdown of the container itself is quite simple. In this case, the tool sudos into the according user, lists their podman containers, filtered by the PID namespace ID that the tool determined previously, and then uses a simple podman kill to shut down the container. A bonus is to only shut down containers of certain users, groups, or really only certain containers, and also tracking which command caused the seccomp offense, so one can adjust their seccomp profile when a false positive happened. And there are probably many more possibilities to implement other filters with eBPF. After the container is shut down, the threat is reduced, the tool did its job, and the incident can be further investigated. Also, if you want to take a look at the tool, the code is also available on GitHub since yesterday. So yeah, that was a short insight into the tool that I've written. And if you would like to know more, feel free to contact us. Thank you.
Yeah. Also, thanks from my side, and thanks for having us.
Cedric. Thank you for presenting, Cedric and Holger. It was a very interesting presentation, and I hope that people will ask some questions already in the chat or in the Q&A section. So please answer those questions there. So and now we have last but not least lightning talk from Krisztian Fekete. Krisztian, floor is yours now.
Hello everyone. Let me share my screen. Okay, so I don't have slides, so instead of that, I will try to build an oomkill-exporter based on eBPF in 5 minutes. So for that, I have a few files prepared here. First, we have this oomkill.c file. This is basically our eBPF code. It's quite simple. It's already only 40-something lines long. Basically, I will walk you through how it works. Basically, if you have an out-of-memory exception happening in your virtual machine or Kubernetes cluster, you might be interested in some details about these events. These details can be different in every use case, but let's say in this simple use case, you are interested in the actual process that got oomkilled. You might be also interested in another process that was running at the time of the oomkill happened. So that might be the culprit in this case. So these are the FPID and the TPID in this case. You might be also interested in how many memory pages were reached by the application at the time of the kill, and we are humans, so the actual name of the processes can be also useful. Once we have the data for all of our out-of-memory events, we can put events described by these fields into a buffer-like data structure. In this case, this is a ring buffer. That's eBPF map type, and basically this is a way to surface this data from the kernel space so that you can access it in the user space. So this is the actual queue used to access that data. You can also notice that I have this .counter suffix added here. I'm adding that here because I'm generating Prometheus metrics based on this data. I will use these labels, these fields as labels in the Prometheus metrics. That will be the name of the Prometheus metric, and this is the metric type that I will use. Apart from this, all you need is this basic code to actually populate these fields. Basically, this is the actual kernel space code that is running every time this kernel probe is being executed in your kernel. So in 40 lines, you can have all the data that you are interested in for out-of-memory exceptions. We can use Bumblebee. It's an open source project by Solo.io. With that, we will generate the Prometheus metrics. So I have this b.yaml file here, which is basically a daemon set. So it will deploy Bumblebee as a daemon set. So every node will run one instance of Bumblebee. And I'm referencing this oomkill image that I just showed to you. Let's create an OCI compatible image from the kernel space code first. For that, we can use the B-CLI, which is basically really like Docker. It's quite simple to generate the code this way. We can do something like b-build, reference the local file and the user tag. After that, we can use we can push it to a local or remote registry, and we can run it. So even we have this text-based user interface. But let's deploy it to the Kubernetes cluster. So for that, let's apply the manifest that I just showed you earlier. What should be up and running. I also have pod monitor and Prometheus up and running. The pod monitor is required because that's where we are scraping the Bumblebee pods. And once we have this, all we need is some application that is running out of memory. So for that, let's apply this memory leaker.yaml. And if we check the pods running here, we can see that memory leaker is in crash loopback, and it's in crash loopback because it got oomkilled. So we want to have some metrics describing this kernel event. So for that, we can go to Prometheus. We can search for the metrics. As I mentioned, the name of the metric is oomkills, and this is the prefix that we use. And here we can already see that all the labels are populated from kernel space into the Prometheus metrics that we just generated. So we can see that the stress program was the one resulting in causing the actual oomkill, and these are the process IDs of the processes running at the time of the oomkill. So based on this, you can easily build graphs, you can have proper alerting, and this is basically a quite foolproof way of catching out-of-memory exceptions. There are many cases when you cannot really catch those, not all the regular Prometheus metrics, and exporters are exposing all of the out-of-memory exceptions. But if you use eBPF and if you hook into this kernel probe, then you will be able to catch all of those. Thank you for your time, and thank you for having me. I was happy to be here.
Thank you, Krisztian. It